So good afternoon and welcome to this session. First of all, let's check we're all in the right room. I think I'm in the right room, but this is a deep dive session. This is NET402. We're going to be talking about Direct Connect and VPNs. My name is Steve Seymour. I'm a specialist solutions architect for networking. I work in Europe, Middle East, and Africa with all of our customers that want to have deep dive discussions on networking. As I say, this is a 400 level session, which means it's an expert level session. We expect you to be deeply familiar with this topic already and actually quite comfortable with how it already works. This is not an introduction level session. So perhaps some existing knowledge you might have. Perhaps earlier in the week you might have gone to Becky's session, NET401, where she talked about some of the connectivity options that we have, and she mentioned Direct Connect and VPN in that session. You might also have seen yesterday's session with Ben and Sid. They talked about how to extend data centers into the cloud. And again, they were explaining how you use VPN and Direct Connect to achieve that. You also might have seen the session that I did last year. It was the same titled session, but it was NET406 last year. And in that session, I actually go through step by step how to configure everything to do with these two services. So I'm not going to be repeating that this year, but all of that content can be found on YouTube, so you can look at it after this event if you need to go back and refresh some of that knowledge. Now, one of the core things that I do expect from this session, and hopefully all of you know this, is the difference between a VPN and Direct Connect. That's really important knowledge. But I also expect you to know the difference between a router and a router. Anyway, let's get started with the rest of the session. So what are we actually going to be covering? Well, obviously we're talking about VPN and Direct Connect throughout the whole session, but I wanted to look at some of the options and the configuration details around those. We're going to talk about resilience, how you can achieve a resilient setup with both of these services, and talk about some of the frequently asked questions that we get as a solutions architecture team about the two services, and touch on billing a little bit as well, just to explain how some of that works. We're then going to go a bit deeper on BGP and how does routing actually work, talking about autonomous system numbers, how routing works within the virtual private gateway. Beyond that, I'm then going to dive into some details around CloudHub and Transit VPC solutions, how you can connect Direct Connect and VPN to other AWS services, and then finally, a full example of how you can configure an IPsec VPN over the top of Direct Connect. So that's the level of depth we're talking about in this session. Okay, so let's start with the hardware VPN solution that we have. Now, the hardware VPN solution is a fully managed VPN solution provided by AWS. It has an endpoint on the AWS side, which is the virtual private gateway, and it has an endpoint on the customer side of the connection that we refer to as the customer gateway. When you create a VPN connection using this solution, we actually provision two tunnels, and those two tunnels give you your resilience into the AWS environment. Each of those tunnel endpoints terminates in a different availability zone. It's a standard IPsec tunnel. So there's nothing unusual about this. It supports standard encryption options, supports AES-256, SHA-2, and also we do now support NAT traversal as well. So if the customer gateway on your side of this connection is actually already behind another router that is doing some address translation, that's fine, that'll work as well. The VPN connection is paid for on an hourly basis for each VPN connection that you have, and that covers the two tunnels associated with that particular VPN connection. And then finally, there are two options for configuring this VPN. It can either be a static VPN, or it can be dynamic or BGP-based in terms of the routing. So let's just quickly refresh ourselves on what those two terms mean, both static and dynamic. So here's an example of a static VPN. In this situation, you actually have to configure specifically the IP addresses that are going to be on each end of the VPN tunnels. Might be also known as a policy-based VPN. So you're going to define that on the right-hand side here, you've got your corporate infrastructure, your data center, and perhaps it's 192.168/16. On the left-hand side, we have our VPC and our two endpoints for the virtual private gateway. And the VPC in this case is 10/16. Now you'll notice here that you can only have one unique security association pair per tunnel. So that's fine in this setup that we're showing here. There is only one set of IP addresses on each end of the connection that we need to be able to route to. So that's two unique pairs for two tunnels. That's 4 security associations. But I'm guessing that a lot of your networks don't simply have 1/16 as part of them, so on the right-hand side of the diagram. And in that case, what you actually need to do is configure the policy-based VPN to be using 0/0. What that means is any traffic can flow over this VPN connection. You then need to use network ACLs on your end of the connection, on your routers, to actually control and manage that traffic. because we need to go back to the fact that we support these 4 security associations across the 2 tunnels. Now, what about a dynamic VPN? Dynamic VPN, again, has the 2 endpoints on the AWS side, but this time, instead of specifying which IP addresses are reachable on each end of the connection, we use BGP, a routing protocol, to announce those routes between each end, between each location. So in this case, we're going to have the 2 tunnels. There's an IP address associated with each end of that tunnel, and then a BGP AS number defining both the customer end of the connection and the AWS end. The AS number that's used on the Amazon side is fixed for each region. But on the customer side, obviously, you can use whatever AS number you like. We'd recommend you use a private AS number, and if you use a public AS number, you should own it. But this is a private environment, it's a VPN connection. Now, if you wanted to achieve a resilient setup with either the static or the dynamic VPNs, you could obviously deploy 2 customer gateways within your environment, within your data center on the right. You can then build 2 VPN tunnels from each of those customer gateways to each VPC that you want to connect to. So in this case, I'm showing 2 VPCs, and you can then expand this as you needed to build the VPN connections out to all of your VPCs. So let's take a look at a couple of the frequently asked questions that I get. Now, quite a common one is, how can I change the pre-shared key on a VPN connection? Now, you might have seen this if you have some experience with our VPN solution already. When you create the VPN configuration, we give you a file to download which contains all the configuration options. It's also a template for a lot of well-known router manufacturers that you can just generally apply. The pre-shared key is within that file. So if you want to change that pre-shared key, what you actually have to do is create a new VPN connection. That will generate a new pre-shared key, and you can then reconfigure it on your end of the connection. But when you do that, you also need to be aware that when you recreate that VPN, we are likely to also change the endpoints on the AWS side of that connection. So the IP addresses you're establishing your tunnels to will probably have changed in that scenario. So in that case, make sure you do reconfigure all of those options on your router. Now, we support a whole range of crypto options on the VPN solution that we have here. So what if you want to change those after you've already deployed the VPN? Well, this is really easy. You simply change it on your end, because the way an IPsec VPN works is there is a negotiation at the beginning of the VPN connection where you make proposals to each other of which encryption options do I want to use. And if you only propose a higher level of encryption, that's fine, that's what we'll accept, and we'll establish that VPN connection. Now, what if you've built your VPC, you've done some testing in it, and now you want to build another VPC, perhaps for production, and move your VPN to that production VPC? You want to reuse that existing VPN connection. This is actually really quite easy because the VPN connection is associated with the virtual private gateway. It's not associated with your VPC. So what that means is you can now detach that virtual private gateway and then reattach it to the other VPC. So very easy to move that virtual private gateway. So how does billing work on VPN connections? Well, as I mentioned earlier, you pay for the connection hours of your VPN connection. So once that VPN is configured, you're then going to receive an hourly charge for it. The other dimension that we have is that you pay for data transfer over that VPN connection. Now, here's a little bit more detail that I didn't have in my session last year, but I want to just give you that kind of slightly deeper view. The first item I have here is, where is the customer gateway? Well, if it's over the internet somewhere, if it's in your data center, then you're transferring this data over the internet. So the data transfer charge is our standard internet out data transfer charge. And obviously, we don't charge anything for the data flowing into AWS. But what if you're using your customer gateway via a Direct Connect circuit, which is the example that I'm going to be talking about later on? How do we charge for the data transfer in that situation? Well, it's charged at the rate for Direct Connect. It's not charged at the normal internet data transfer rate. There's also a scenario where you might have deployed your customer gateway actually as a virtual machine in another VPC. And if that VPC is in the same region and you're reaching it via its elastic IP address, then actually you're going to pay the data transfer charge for regional data transfer. It makes sense. The IP address is within the region, so we're not going to charge you for internet data transfer out. We charge you for regional data transfer. And then finally, again, you could have deployed your customer gateway as a software solution in a VPC in another AWS region. And again, in that case, the billing will be based on data transfer to a remote AWS region. So there's a couple of other dimensions there to the billing. So now let's also just touch on what is Direct Connect. Well, Direct Connect is a dedicated private connection into AWS. You can create private or public virtual interfaces that give you access to either your VPC or other AWS services that have public IP addresses. It enables you to benefit from reduced data transfer rates. Data transfer in still remains free, obviously, but data transfer out is at a lesser rate than internet data transfer. It gives you this consistent network performance. You can obviously configure the environment for redundant connections. Although you might only provision one Direct Connect connection or multiple, you can actually share these across all of your AWS accounts. And it's a very common setup we now see with customers where they have multiple accounts. So you can actually share these Direct Connect connections between them all. And then finally, Direct Connect uses BGP for exchanging routing information. So there is no static option on Direct Connect. So a bit of terminology about the connections. These are probably terms you're fairly familiar with, dark fiber, Ethernet private line, pseudo-wire, these kind of things. Basically, these are all layer 1, layer 2 type services, effectively an Ethernet connection. So when you connect into an AWS Direct Connect router at one of our locations, it's probably going to be using one of these mechanisms. If you happen to be in one of our Direct Connect locations, and you have your equipment in a rack at one of those, this might be as simple as ordering a cross-connect. So you order that from the data center provider. The cross-connect might go under the floor straight into the AWS routers. We use single-mode fiber connections, either 1000 base LX for 1 gig connections or 10G base LR for 10 gig connections. And they're the two port speed options that we have, 1 gig or 10 gig. And that's a dedicated port for you. If you're not, though, within those Direct Connect locations, within those colo facilities, you might be using a Direct Connect partner to get this connection to you. But there will always be a router on the other end of that connection that needs to talk BGP over a VLAN. So I said there that this is a dedicated connection, a 1 gig or a 10 gig port. Well, what if you actually want a lesser amount of bandwidth? So I just wanted to clarify here the terms that we use. So a 1 gig or a 10 gig port is fairly clear. It's a port on a router that now is assigned to you, and you connect into it. You get the full port speed available for your use, and you can configure as many virtual interfaces, public or private, on that connection as you need. With a hosted connection, though, this is provided by some of our partners. It enables you to get sub 1 gig connections, so 50 meg through to 500 megabits per second. It's actually provided on an existing connection we have with that partner. We call that an interconnect. And when they create a connection for you, it becomes a hosted connection. That hosted connection defines a bandwidth, the 50 meg through to 500 meg, and a VLAN. Because it's already defined the VLAN, when you create a virtual interface on that hosted connection, you can only create a single one of them. And I'm going to look at that in a bit more detail in a moment. Now, I've mentioned the term virtual interface a couple of times, and public and private virtual interface. Now, virtual interface is quite often known by the term VIF. I realize that's used in the industry, generally for quite a few things, but this is a public and a private VIF we're talking about here. A private VIF connects you to your virtual private cloud, your VPC. But what it doesn't give you access to in your VPC is the DNS resolver that we provide. It's referred to as the +2 DNS resolver. It's on the base IP address of your VPC +2. You can't reach that over a private VIF. Equally, you might have a VPC endpoint for S3 on your VPC. You can't reach that over a private virtual interface either. But otherwise, EC2 instances that are deployed within your VPC, you can reach those over a private virtual interface. So what about a public virtual interface? Well, again, the clue is in the name. It gives you access to public AWS services. These are services that are exposed on the internet and that you can reach normally over an internet connection. But in the case that you want to use Direct Connect to reach those, you create a public virtual interface. It gives you access to any of our public IP addresses in the associated AWS region, and it also gives you access to anything else that is running on AWS IP addresses within that region. The other thing that's included within those public IP addresses are the VPN endpoints for the managed VPN that I mentioned a moment ago. And at the end of this session, that's the example I'm going to show you of how to configure an IPsec VPN over a public virtual interface. So a little bit more about virtual interfaces. Well, what do you actually need to configure? It's very simple. You've got three choices. First of all, is it public or private? I need to choose a VLAN for this particular virtual interface. And when I've done that, I need to configure some BGP options. So these are the three core components of a virtual interface. Now let's take a look at how we pull these together. So we have your account here, and within it you've created a 1 gig or a 10 gig Direct Connect connection. On that connection, you're then going to go and create a virtual interface. And when you do that, it will be assigned an identifier, DXVIF. DX is the abbreviation we use for Direct Connect. And you will have chosen a VLAN for this particular virtual interface. You can create multiples of those. So if you have another VPC that you want to reach over this Direct Connect, you simply create a second virtual interface, and a third, and as many more as you need on that regular connection, that 1 gig or that 10 gig port. I mentioned that you can also share these across accounts, so how does that work? Well, if you've got multiple AWS accounts, you go into the account that has the connection, you create a virtual interface as normal, but there's an option to enter another AWS account number. When you do that, you finish configuring the VLAN and the BGP options, put in the account number, and when you submit that, it will appear in the other AWS account ready to be accepted. And at this point, it becomes what we call a hosted virtual interface, because it is hosted on the connection in another account. And you can repeat this, so you can create as many of those as you need as well on a regular connection. What about the situation where we have a partner providing the sub 1 gig options, the 50 through 500 meg options? Well, I mentioned earlier that the partner will already have an interconnect with us. So that's already in place. You don't need to order any physical components on the AWS side. You still might need a connection from that partner to your infrastructure, but you don't have to create the connection in the AWS console. What you actually do instead is give your AWS account number to the Direct Connect partner. They will then provision a hosted connection for you on their interconnect, and it will appear in your account to accept. It will show up with a particular VLAN already assigned to it and a defined bandwidth. But you still need to then create the virtual interface on that hosted connection. The only difference here will be that the VLAN has already been set. And you'll see that it's exactly the same screen that you've already been looking at to create a virtual interface on a regular connection, but the VLAN field will just be grayed out because it's already been chosen by the Direct Connect partner. But I said that a virtual interface requires a choice of public and private, a VLAN and a BGP session. Well, one of those decisions has already been made for you. So if you want another virtual interface, whether you're going to use it in the same account or another one, you actually need to go back to the partner and ask them to provide you with another hosted connection. So in this case, I'm showing it as VLAN 102, and at that stage, you can then create another virtual interface on that hosted connection. So how do we deal with resilience with Direct Connect? So I'm showing here 2 Direct Connect locations. Now, we have multiple locations for most of the AWS regions, and this means that you can deploy very resilient connectivity solutions to the right of this diagram facing your network. In each of those Direct Connect locations, we have at least 2 Direct Connect routers, so even within a single facility, you can have redundant connectivity. These 2 Direct Connect locations, though, need to be connected back to an AWS region. So here we have an example of an AWS region with multiple availability zones and the 2 transit centers associated with that. Each Direct Connect location then has diverse and resilient connectivity back to that region. So you can now build a very resilient, very highly available solution using Direct Connect. So a couple of FAQs on Direct Connect. What if you want to move that connection that you ordered in one account to another account? Well, the first thing is don't delete it. Because if you do, what's going to happen is you'll have to start the process of ordering that connection again. And we're going to then send you a new LOA, letter of authorization, connecting facility agreement, that defines where that port actually is. And it will be a different port to the one you had previously. So now you're going to have to move your cross-connect, etc. So don't delete the port if you want to do this. All you need to do is raise a support case. We will happily move that, assuming you own both accounts, obviously. And we'll move that between the accounts or rename it based on your request. So simply don't delete it. You've created a virtual interface. It's attached to a virtual private gateway. That's how we connect into our VPC. What if we actually want to move it to another virtual private gateway? Well, in this case, what you need to do is actually note down the settings that you use, so the BGP options, the VLAN, etc. You can then delete and recreate that virtual interface using the same settings. If you need to delete a virtual private gateway, you will need to remove all of the virtual interfaces first. If you're doing a public virtual interface, you need to reach the public side of the AWS network. You're going to need to be using public IP addresses on that connection. What if you don't have any that you are willing to use on this particular connection? What if you don't own your own IP addresses? They just come from your ISP. That's no problem at all. We are happy to provide you with a /31 of public IP addresses to use on a public virtual interface. All you need to do is raise a support case and ask us to provide that to you. And then finally, what if you want to change the bandwidth on one of those hosted connections, the 50 through 500 meg connections via Direct Connect partners? Well, what you need to do there is go back to the partner and actually ask them to create you a new hosted connection at the new bandwidth. They can do this in parallel to your existing one. It's on another VLAN. You can configure another virtual interface and attach it to your VPC. and then you can simply remove the old one. There is no need for downtime in this situation. You can simply create a new one, then deprovision the old one. How does billing work on Direct Connect? Well, quite similarly to the VPN side of things, we charge for the hours that you have a Direct Connect connection, and it's charged from the moment that it comes up for the first time. So obviously, there is quite often a period of time from when you order the connection from AWS to the point in time at which your carrier, your partner, can actually deliver it to your facilities. So in that window, we don't charge for that connection. When it comes up for the first time, that's when we start the billing process. Over Direct Connect, you have reduced data transfer rates, so you pay for data transfer. And it's worth remembering, as I said earlier, that if you're running an IPsec VPN over that Direct Connect public virtual interface, you pay for the data transfer at the Direct Connect rates. Now, if you have a private virtual interface, billing for this is very simple. All the data transfer that goes out via your virtual private gateway over Direct Connect is charged for at the Direct Connect rates. But what about a public virtual interface? Because a public virtual interface is giving you access to all of the things on public IP addresses, all of the services that we have, other services that other customers are publishing on AWS. You can access all of those over public virtual interfaces. So how is that built? Well, first of all, let's keep it really simple. If you're accessing a resource that you own, let's say an S3 bucket, then it's quite simple. You pay for that data transfer, and it's charged for at the Direct Connect rates. What about accessing a resource that is owned by another account, but it's part of your consolidated billing family? So many of you might have multiple AWS accounts that all come into one consolidated bill. If you're accessing an S3 bucket that is owned by another AWS account, but within that same consolidated billing family, again, you'll pay for that, and you'll pay for it at the Direct Connect rates. But what about if you're accessing something that I own, something that another customer on AWS is providing from the platform? And in that case, you don't pay for that data transfer. They pay for that data transfer. So some of you might have seen the announcement earlier today. We announced that we now support IPv6 in VPC. We launched in the Ohio region this morning. And therefore, we also support now IPv6 on Direct Connect. So I wanted to give you a bit of an insight into how that's actually going to be working. So when you create an IPv6-based peering session on a virtual interface, we're going to be supplying you with a /125 CIDR block for that particular connection. You won't be defining your own IPv6 addresses for the connection. If you haven't seen, also within VPC, again, we'll be assigning you address space from Amazon's IPv6 allocation. We will accept /64 or shorter prefixes from you over the BGP session. And the way this works is it's actually an additional peering session on top of your existing virtual interface. So you'll have an IPv4 peering session and an IPv6 peering session. And it is supported on both public and private virtual interfaces. So this is what it looks like. On the screen here, I'm showing you an existing virtual interface. It's down at this point. I haven't finished configuring it at all. But what we're going to do at the top here is click on the Actions menu, and you'll see there is now an option to add a peering to this virtual interface. Until this point, it's only an IPv4 connection, which is now up and running, but I want to add IPv6 to it. So we add a peering. We choose IPv6. Now, you can only have a pair of peering connections on this virtual interface, one IPv4, one IPv6. So in this case, because IPv4 already exists, this is going to be an additional IPv6 interface. Auto-generate IPs, as I mentioned, we're going to provide the IP addresses for the peering session itself. You simply specify the AS number, and if you want to specify one, the BGP key that you're going to use for this session, and then click Go. You'll then see an additional tab appears on that virtual interface showing you both the IPv4 and the IPv6 sessions. You can, of course, go back, and if you started with an IPv6 peering session, add an IPv4 session to it. So it works both ways. You could start with either peering and add the second peering afterwards. So I mentioned BGP a few times, so a quick refresher on that because we're going to have to dive into some of the detail of this next. So BGP is a TCP-based protocol for exchanging routing information. More specific prefixes or routes are always preferred. We use autonomous system numbers to identify the networks on each end of a BGP session, and that session is established between two BGP neighbors. iBGP is the term that's used for BGP peers within the same AS number. eBGP is the term used for peers within different ASs. And whenever you're doing BGP with AWS, you're going to be using eBGP. It's always going to be two different AS numbers on the ends of the VPN connection or the Direct Connect. AS path is a really important concept. It's a measure of network distance. So it's not the same as a trace route with the amount of hops in it, but it represents the whole network that you're passing traffic through. And on the AS path, it will be identified by a number of the particular networks that your traffic is passing through. You can always configure a local preference to push traffic down a particular connection if needed. So a bit more on AS numbers, autonomous system numbers. If you look up Amazon in one of the internet routing registries, you're probably going to see that our AS number is 16509. There's a few others out there as well, but that's our main AS number. But when you create a public virtual interface and you download that configuration, remembering it gives you access to all of Amazon's public IPs in that region, you're actually going to see that the AS number is probably 7224. It's not 16509. What about when you create a private virtual interface? What's the AS number that we use on the Amazon end of a private virtual interface or on a dynamic VPN? And the point here is that it can vary. So please don't make any assumptions about what the AS number is going to be. As an example, here's some of our regions just specifying what the AS numbers are. So always download the configuration. You can do this in a couple of ways. So if you create a virtual interface, there's always a link to download the configuration. Within that will be the AS number that we're using for that particular connection in that region. The same for a VPN connection, and obviously you can also do this via the command line tools. So always check what the AS number is on the Amazon end of your VPN or Direct Connect connection. Now that public virtual interface that gives us access to all of Amazon's public IPs in that particular region, it requires public IP addresses for the BGP peering session. As I mentioned, you can open a case with AWS support if you need a /31 to use for that, but if you have your own IP addresses, you can announce those to us. When you create the virtual interface, you specify those IP addresses. We then whitelist them to accept them into our network once we've verified that you own them, and then you can use those. If you're going to use an AS number that is public, you have to own that AS number on a public virtual interface. If you don't, that's absolutely fine. You can use private AS numbers. But if you specify a public one, again, we're going to verify that you actually own that before we enable that virtual interface. And that's why there's a window of time, up to about 72 hours possibly, to validate the ownership of those IP addresses and that AS number. Public virtual interfaces in the US also enable you to reach all of the AWS regions within the US. This is a US-specific feature, but it means that you're going to receive BGP announcements for all of Amazon's IPs in all of the AWS regions in the US. Now, going back to the AS path comment I made earlier, this is an example of the output for a particular prefix on a router that is connected over a BGP session via a public virtual interface. You can see on here that there's an AS path. 7224 is the AS path, the AS number that I mentioned that we use for Direct Connect. You can see it twice in the path there. You also see that we then have 16509, which is the Amazon AS number I also mentioned earlier, and represents where this particular prefix originates within our network. What you've got here is an AS path length of 3. So we have 7224 in there twice deliberately. One step further than that, we actually have what's called a community attached to this particular BGP announcement. It's called the no export community. And the reason we've done that is it helps prevent any unintended propagation of these routes beyond your AS boundary, so beyond your network. You can, of course, override things like no export if you happen to use multiple AS numbers internally, but this is a measure to help prevent these routes being leaked beyond your network and limit the impact if that were to happen. As I mentioned, you can have an inter-region public virtual interface. This is enabled by default, which means you're going to receive all of these prefixes for all of those regions in the US. But what if you don't actually want to use them? What we do here is we actually tag our announcements with particular BGP communities to help you decide what you want to do with them. So you can see here that if it comes from the local AWS region that you connected this virtual interface to, it's going to be tagged with the 8100 community. If, however, it comes from somewhere else on the continent, so somewhere else within the US, then it will be tagged with the 8200 prefix. Equally, you can announce prefixes back to us and tag them with a particular community to limit how far we distribute those within our network. So if you only want your public IP addresses to be routed from within that local region, that's fine. You just add the 9100 community to those announcements. So here's an example of those communities attached to this particular announcement. You can see we've got 7224, 8100, and 8200. Well, obviously, a region is within the continent, so that's why you've got both communities attached to this particular announcement. So a few more considerations around the AS path that we should think about when we're doing multi-region deployments on AWS. So here's the scenario that we're going to be working with. We have 3 VPCs in 3 different regions. One in US East 1 in North Virginia, one in US West 2 in Oregon, and one in EU West 1, which is in Ireland. You can see just under the VPC there, I've put the AS numbers that we use for the private virtual interface in those particular regions. And you might notice that the EU West 1 Ireland region uses a different AS number. It uses 9059. All of these are connected to a corporate backbone. It might be your own backbone. It might be managed and provided to you by a partner. But I'm representing that here by a particular AS number, 65,000. So let's take the scenario where we want to be able to send traffic across this corporate backbone, for whatever reason that you have, between US East 1 and US West 2. Both of them use the same AS number, 7224. And in the BGP environment, what that actually means is when you announce that route from US East on the left, across your corporate network, where we add then the 65,000 AS number to the AS path, when it gets to US West 2, we're actually going to reject it. And that's because to us, it appears to come from the same AS number, and it could cause a routing loop. So on our side, we're going to reject that announcement from your router. But actually, you wanted this to happen. You wanted to be able to communicate between those 2 VPCs. So how can we fix that? We're using an example here for a Cisco router. You can apply something called AS override on your router facing that region. What that means is, if I see the AS number in the AS path for the network that I'm about to announce the network to, I'm going to override that. I'm going to replace it with my AS number. So you can see here in green the 65,000. That's the backbone AS number, at which point we will happily accept that announcement into the US West region. Now, obviously, if you do the same for the reverse path, this time from US West 2 back to US East 1, the same is going to apply. So let's put AS override in place to deal with that. Now, you may not have to configure this on your own equipment, but it might be something that your partner, your carrier, may have to do. Let's take another scenario using that same environment. This time we've got EU West 1 in Ireland wanting to be able to send traffic to US West 2. Well, in this case, EU West 1 is using a different AS number, 9059. So if we look at this path here in the middle, we can see 65,000, 9059, everything's good. We announce that to US West 2, which is 7224. It's accepted, no problem. There's no routing loop as far as BGP is concerned. Let's do it the other way around. US West 2 announces from 7224 via the backbone 65,000 into EU West 1. Now, EU West 1 is 9059, so everything should be good. But if you actually set this up, you'll find that it is rejected. Why is that? Well, it's because internally we actually use 7224 for quite a few of the internal environments for Direct Connect. So what do we do in this particular situation? Well, you could try and apply AS override like we did before. But you can see here in the example, it actually won't do anything because the peering session is with 9059. That's not the same as 7224, so AS override does not apply. So it's still rejected. Now, there's a few variations of how you can deal with this situation. This is BGP engineering that you can do. One example I wanted to use here was that you could actually change the way you're announcing routes into the EU West 1 region. You can actually configure your router, the last hop before the VPC, to originate a default route. So this time, this route, this 0/0 route, is going to originate from your 65,000 network. And of course, we're going to accept that because there is no routing loop, there's no 7224, there's no 9059. But this probably isn't quite what you wanted to achieve. You didn't want a default route, you just wanted to route to the other VPCs across the globe. So now let's look a little bit more about how the virtual gateway works with this. So here's our VPC. We've got our BGP session with our default route being originated on the right-hand side. So now the virtual private gateway has a default route inside. But your VPC probably also has an internet gateway, which also routes out to the internet. It's probably what you intended to use as your default route. Well, the good news here is that those 2 options are actually separate from the route tables inside your VPC. When you create a route table, it has a local route in it, which says, this is how I get to all the IP addresses within my VPC. You've then probably created a default route that says, send all traffic to the internet via my internet gateway. What you can actually do here is put a specific route in that route table inside your VPC just for the 10/8 network. And in this case, you can say, if I have traffic for 10/8, send it to the virtual private gateway. So what you're seeing here is two steps in the routing process. There's a decision that's made inside the route table that you configured, and then once that traffic gets to your virtual private gateway, it's going to follow that default route anyway, down the Direct Connect, onto the corporate backbone. So you have actually achieved your goal of being able to route to the rest of your 10 network over Direct Connect, even though you might have some overlapping AS number configuration issues. So while we're talking about routing within our VPC, we might have multiple routes to get to a particular destination inside that route table. They could have come from various places. You could have created them manually. They could have been propagated dynamically from Direct Connect or VPN. So how do we make a decision about where to send that traffic? Well, the first thing to say is that local routes within the VPC always come first. You cannot create a more specific route in a route table in a VPC than the VPC CIDR itself. Assuming that the choice now has to be made between two routes that are outside of that VPC, the first thing we're going to do is look for the longest prefix match first. So a /24 is more specific than a /16 route. Assuming that hasn't broken the tie, we're then going to have a look and say, any route that appeared as a static entry, one that you created inside that route table, that will win. Okay, but perhaps that didn't split the match we have here. So now we're into the dynamic routes. If we have a dynamic route via Direct Connect and via VPN, the first thing we're going to do is choose Direct Connect. It's unlikely that you intended to use a VPN connection if you had a Direct Connect in place. So Direct Connect wins first. If we still need to break a tie here, we're going to look at the shortest AS path. And finally, at this stage, we say, OK, we have two paths to a remote network. We're going to do ECMP, equal cost multipathing, and use both of those connections. Assuming it wasn't a Direct Connect decision we needed to make, static VPN connections now come before dynamic VPN connections. So this is the routing preference that we have inside the VPC. So now let's talk about something called VPN CloudHub. You might have seen this in the documentation. VPN CloudHub is a way that you can connect multiple remote networks, these could be your data centers, your corporate offices, all into the same virtual private gateway. Assuming that you configure them with different AS numbers here, you'll be exchanging routes via the virtual private gateway. It acts as a hub, hence the name CloudHub. It also, of course, gives you access into the VPC, as you'd expect. You can use different AS numbers, but you also have the option to use the same AS number if you wanted to, although you might need to do some custom configuration on your routers to make that work. I also wanted to show an example here where instead of connecting multiple offices or multiple data centers together, you could, of course, deploy another VPC, perhaps in a different region. So up on the top right, I'm showing EU Central 1. This is another region. I've deployed 2 software VPN instances in that region. I've deployed 2, obviously, for high availability. So these are now my customer gateways. They connect to the virtual private gateway on the left, and now we're able to route between your data centers and 2 different VPCs in 2 different locations. That works really well. You can expand that, of course, and now put another 2 software VPN instances in another VPC, build a whole set of VPNs to that virtual private gateway, and now all 3 of these VPCs, wherever they're located, will be able to route to each other. Let's add a corporate data center back into the mix here. Let's add a private virtual interface connected to that same virtual private gateway, and now all of these environments can all route to each other. So you can come over one Direct Connect into one particular region, then over these VPN connections out to the others. Isn't this starting to sound like a transit VPC? You've created an environment where you can route to multiple locations over this one connection. But there's a problem with this design. Whilst technically it works, we've had to deploy 2 software VPN instances in every single VPC that we want to add into this environment. Those 2 software VPNs might be running commercial software that you're having to pay license fees for, and you now need to deal with the resilience of them within that VPC. What happens when one of them fails? That's what we should always be planning for. So we now need to have some automation that fails over our routing. All of this is completely doable, and we actually have examples of this published. But actually, there's an easier way. We published a transit VPC solution recently. What this does is it moves those 2 software VPN instances into a hub environment. So we actually create a VPC here. We're not using anything else within it, just to hold these 2 VPN instances. These 2 VPN instances act as the customer gateway, and they connect out to the virtual private gateway of as many other VPCs as you need. Because it's going to a virtual private gateway on the other end, you haven't even got to think about the resilience within those VPCs, A and B at the top, because you have one target in your route table, the virtual private gateway. You don't have to script any failover. You just say, send my traffic to the virtual private gateway, and we take care of it for you. In the hub, we have the 2 VPN instances, so that's highly available and resilient. If one of those fails, all of the traffic will just keep flowing over the other one whilst it gets replaced by whatever automation you want to implement. Now, we've actually published a CloudFormation template on automation around this for you. It allows you to do things as simple as tagging a virtual private gateway with a spoke tag. We then use Lambda to automatically notice that, build a VPN configuration, and configure these 2 software VPN instances in the middle for you. So you can go and download that from our website, give it a try, customize it as much as you need. And that's great for connecting VPCs together in multiple regions if needed. But also you probably want to connect it back to your data center. So at the bottom here, if you were using a VPN connection, you could bring those straight into those 2 EC2 instances in the middle. But if you're using Direct Connect, how does that work? Well, you can actually create a virtual private gateway. It doesn't have to even be attached to a VPC. You can bring your virtual interface for Direct Connect into that, and then tag it again with the spoke VPN tag. That will then add it into this transit VPC. And now you'll be able to route between Direct Connect and all of those other VPCs at the top of the diagram. So as I say, there is a full solution brief documented about this. It shows you how to configure all of the components, how to automatically deploy it, and I'd encourage you to take a look at that and customize it for your own needs. So how do we use VPN and Direct Connect with some other AWS services? Let's touch on public virtual interfaces first. It connects you to those public services we talked about, anything within that local associated region, and things like Amazon S3, Amazon Glacier, DynamoDB. These are the kinds of services that you're going to connect to over a public virtual interface. But what about these services? These might be ones that you're considering, actually, aren't these private? Well, no, all of these actually have a public component to them. Workspaces, you connect to the endpoints for workspaces over the internet, so they have public IP addresses. Elastic load balancing, yes, you can have internal elastic load balancers, but you also generally deploy them with public IP addresses facing the internet. So these are all reachable over a public virtual interface. Now, what about a private virtual interface? It goes to your VPC, so I think we can keep those same services on the screen because Workspaces has a component that does exist inside your VPC as well, so it's relevant for that. Lambda, again, you can create Lambda functions and run them inside your VPC, so that's relevant. And of course, EC2. EC2 instances are running inside your VPC. Other services, though, that you might not expect to see there, you've got things like RDS, Redshift, Cloud HSM. These are all reachable over private virtual interfaces. So let's take an actual example here. Let's work with Storage Gateway. For those of you not familiar with Storage Gateway, it's a virtual appliance that you deploy in your virtualized environment on premises. You can then use your legacy servers and backup software that supports virtual tape libraries to connect to the Storage Gateway over iSCSI. What Storage Gateway then does is it can either act in a cached mode or a gateway mode, but it will then take your data and push it into a service on the AWS side via some public endpoints. So these exist for a particular region. They have public IP addresses. This normally works over the internet. So I think you can see quite clearly here that if we put a Direct Connect in place, you could replace that connection over the internet, potentially high bandwidth usage that's going over your current internet connection. You could replace that with a Direct Connect. The other scenario is Amazon Workspaces. So again, this might be an architecture that you've seen before. It's quite a standard setup of workspaces. On the left-hand side, we have your data center. We have various servers deployed within that environment, perhaps some directory servers, multi-factor authentication servers. You also have your users within that environment who want to connect to their workspaces. And when they connect to the endpoints for workspaces, they go over the internet. They're exposed to the public internet so that you can log in from anywhere. There's usually already a VPN connection within a solution like this because our directory service wants to integrate with your directory. So that VPN connection is in place. And as we know, a private virtual interface can be used wherever we're using a VPN connection. So that's one place in this solution that we can use Direct Connect. But there is one more. Those connections from those users when they're in the corporate office, within the corporate environment, if they want to reach these public endpoints, if we put a public virtual interface in place, they can actually connect over those. We aren't limiting their ability to connect. You can still connect from home or from a coffee shop, wherever you need to use workspaces. But if you're in the office, you can benefit from that Direct Connect connection if you deploy a public virtual interface. Okay, so I sometimes hear the request from customers that they want to use Direct Connect, but it's not encrypted. How can I encrypt a connection over Direct Connect? Well, this is one of the options for doing that. There are many ways of doing it, and I showed this example last year. It's a very high-level diagram. It's saying that on the right-hand side, we have your corporate network, we have a router there. We create a public virtual interface, which is the blue line on the diagram here, the configuration at the top, everything we've talked about so far. Because the IP addresses for our VPN endpoints are presented within that public address space, you can now build a VPN connection on top of that. That's the two dashed green lines on the diagram here. The configuration for those two IPsec tunnels is shown at the bottom of the screen, and this is what you'd need to configure. But how do you actually do this? So what I'm going to show you is one particular example. It's configured on a Cisco router. You can do this on various vendors' hardware. And it uses something called virtual routing and forwarding, VRFs. So a VRF allows you to create a separate environment within that router. It's sometimes called a routing instance on other vendors' environments, other vendors' hardware. You can create a separate routing table within that router. It means that the main route table can be associated with an internal private network, and you can contain a set of other routes completely separately to that route table. So what we have here, I've created a VRF, virtual routing and forwarding environment, for a public virtual interface. I'm then going to build that public virtual interface between AWS and that VRF. Now, when you create a public virtual interface, you download a configuration. It looks something like this. But what I've done here is added in the extra lines to now use a VRF on this particular router. So these examples can actually be used and applied if you want to. There's a few other elements you might choose to add to integrate better with your network, to add some additional security, but these are the core components. Once you've configured the VRF for that public virtual interface, if we now look inside that route table inside the VRF, we're going to see all of those Amazon public IP addresses. Within those are the IP addresses for the virtual private gateway. So the next step is to create a VPN connection. And again, when you download the configuration, this is what it's going to look like. What you can do here is say, when I establish this VPN connection, establish it from within that VRF. Use the routing that I have available from that public virtual interface to reach the VPN endpoints. So I'm showing you here the places that you need to add in that additional configuration for your reference, that you can use this perhaps after this session to try out this configuration. Basically, though, you're configuring the key rings and the profile for the VPN connection. Once you've configured those two elements, though, you also have to take the two tunnel interfaces themselves. And here it's really important to configure those tunnels to start within that VRF. We don't need the whole interface to be in there, so there's no configuration here to put the interface itself in the VRF, just the start of the tunnels. So when that's done, what we now have is the configuration of two tunnels that have part of them inside that public VRF and part of them within the global routing table on the router. We bring up the BGP sessions between these two, and now if we have a look at the route table on the main part of the router, the global routing table, it's nice and clean. All it has in it is a route to my corporate network, 192.168.51 in this example, and it has my two paths via two VPN connections into AWS. So this is one way that you can build an encrypted connection on top of Direct Connect. So these are a few of the other sessions that cover Direct Connect and VPNs. There's quite a few there. As I say, most of them have already occurred this week, so you can catch them on YouTube after the event. Hope the session has been useful to you. We'd really appreciate your feedback because I shaped this session based on some of the feedback we had last year, and we're always looking to improve the content. So thank you very much for your time. We've got about 10 minutes if anyone's got any questions.